Welcome to the DIY Honda Garage channel. Welcome to this detailed troubleshooting guide for the DTC P006A-00, which indicates a mass airflow MAF sensor circuit range or performance problem specifically for the 2023 and newer Honda CR-V models. This diagnostic trouble code, DTC, is set when the powertrain control module, PCM, detects a discrepancy between the airflow measured by the MAF sensor and the airflow estimated by the manifold absolute pressure MAP sensor. The PCM continuously monitors these sensors during operation. If the measured airflow significantly deviates from the expected range, the PCM registers this as an error, resulting in the P006A code. Understanding this issue is crucial as it can affect engine performance, fuel efficiency, and emissions. In the following slides, we will delve into the error's components and causative factors that could lead to this DTC being set. The DTC P006A-00 involves the mass airflow MAF sensor and the manifold absolute pressure MAP sensor. The primary role of the MAF sensor is to measure the volume of air entering the engine, which is a critical input for the PCM to determine the appropriate fuel-air mixture for combustion. The MAP sensor assists in measuring the pressure in the intake manifold, which helps the PCM calculate the airflow based on engine conditions. Both sensors are located within the engine intake system, with the MAF sensor typically found in the air intake duct before the throttle body. If the readings between these two sensors differ beyond acceptable thresholds, the PCM concludes that there is a performance problem, consequently logging the P006A error code in its memory for further diagnostics. There are several potential causes for DTC P006A-00 that warrant inspection. First, a faulty MAF sensor could lead to incorrect airflow measurements, thereby triggering this diagnostic trouble code. Secondly, issues with the MAP sensor can also result in discrepancies between the expected and actual airflow readings. Lastly, leaks or blockages in the intake air system can alter the airflow dynamics, resulting in a misunderstanding by the PCM about the engine's intake air volume. Each of these causes needs to be investigated rigorously during the troubleshooting process to ascertain the root issue and avoid misdiagnosis. When DTC P006A-00 is present, various symptoms can manifest in vehicle performance. One prominent symptom is poor engine performance, which may manifest as reduced power or sluggish acceleration, making it difficult to drive under normal conditions. Increased fuel consumption is another common symptom. Improper measurements from the MAF and MAP sensors can lead to an erroneous fuel-air mixture, resulting in excess fuel usage. Additionally, drivers might experience engine misfires, where the engine sputters or has difficulty maintaining a steady RPM. These symptoms should be monitored closely, as they may indicate further complications if the underlying issue is not resolved. The first step in troubleshooting DTC P006A-00 involves starting the engine and maintaining the engine speed at 3,000 RPM without any load, meaning that the vehicle should be in park or neutral. This step continues until the radiator fan activates, signaling that the engine is at a certain operating temperature. Following this, let the engine idle for a moment before conducting a test drive. During the test drive, it is important to maintain the vehicle in the same parameters as indicated in the onboard snapshot parameters, which include monitoring engine speed, vehicle speed, MAP sensor voltage, and throttle position, TP sensor readings. Simultaneously, the Honda Diagnostic System, HDS, should be used to monitor for the presence of DTC P006A-00. This step helps confirm whether the issue persists under specific operating conditions. In this second step, focus shifts to inspecting the positive crankcase ventilation PCV system, components, and connections. Begin by checking the PCV valve, which is crucial for regulating the flow of gases from the crankcase back into the intake system. Look for any visible damages to the PCV hose and the purge line connecting to the intake manifold. It is essential to ensure that there are no leaks or blockages in these components, as they can significantly affect airflow measurements. Proper connections are vital to maintain the expected performance of the intake air system, which directly influences the readings of both the MAF and MAP sensors. If any issues are identified during this inspection, they need to be rectified before proceeding further. The third troubleshooting step requires a visual inspection of the intake air duct and air cleaner housing. It is essential to verify that all connections are secure and components are free from damage or blockages. Any obstructions in the intake air duct can hinder airflow, leading to erroneous readings from the MAF and MAP sensors, ultimately resulting in performance issues and the triggering of DTC P006A-00. Additionally, the air cleaner housing should be checked for cleanliness. A clogged air filter can restrict airflow significantly. Ensuring that there are no blockages or damages in any parts of the intake air system is critical for the effective functioning of the engine and accurate sensor readings. The fourth step involves conducting a functional inspection of the MAF sensor using the Honda Diagnostic System, HDS, while the engine is off. During this process, it's important to confirm the sensor readings. Under normal conditions, the MAF sensor reading should be approximately 0.2 grams per second, G per second. If the reading significantly deviates from this expected value, it may indicate a fault within the MAF sensor itself, which could lead to the DTC P006A being stored. Properly diagnosing sensor operation at this juncture can help in isolating the problem to either the MAF sensor or related components, allowing for targeted repairs. For the final troubleshooting step, start the engine and monitor the MAF sensor readings on the HDS while varying the engine speed between 2,000 and 3,000 RPM. It is essential to observe how the MAF sensor responds to changes in engine speed. Under normal functioning, the sensor readings should progressively change corresponding to the engine speed fluctuations. If the readings are erratic or do not change at all, it may indicate an underlying problem, either with the MAF sensor or the intake air temperature IAT sensor, which is often integrated with the MAF sensor assembly. This evaluation helps determine whether the MAF sensor is functioning properly and is an essential diagnostic step to confirm the integrity of the airflow measurement system. After completing the necessary repairs identified during the troubleshooting process, it is vital to clear the DTC and conduct a thorough test drive. This step involves utilizing the HDS to erase any stored trouble codes, including P006A-00. After clearing the DTC, it is crucial to monitor the vehicle's performance by test driving under various conditions to ensure that all systems are functioning correctly. Pay particular attention to any signs of engine performance issues and confirm that there are no reoccurring DTCs. If the DTC does not return and the vehicle operates as intended, the repairs can be confirmed as successful. This verification step is important not only for ensuring that the immediate issue is resolved, but also for preventing future complications. For effective long-term vehicle health, prior DTC P006A-00, it is advisable to incorporate preventive maintenance measures. Regular inspections of the MAF sensor can help ensure its accurate functioning, as this component is pivotal for measuring intake air and impacts the vehicle's overall performance. Additionally, The air filter condition should be routinely checked. A clean air filter facilitates proper airflow into the engine, preventing unnecessary strain on the MAF sensor and improving fuel efficiency. Furthermore, ensuring that all intake air system components are well maintained and free from blockages can enhance the overall performance and longevity of the engine. Establishing a regular maintenance routine can mitigate issues such as the one indicated by DTC P006A-00. In conclusion, understanding the roles of the MAF and MAP sensors is essential in diagnosing and troubleshooting DTC P006A-00 effectively. Proper inspections for faults within these components and associated intake systems are crucial for identifying the root cause of the problem. The troubleshooting steps outlined provide a comprehensive approach from initial checks to final verification, ensuring a systematic resolution of the issue. Additionally, incorporating regular preventive maintenance practices can significantly reduce the risk of encountering similar issues in the future. A well-maintained vehicle not only performs better, but is also more efficient, providing an overall enhanced driving experience. Please like and subscribe to the channel. See you next time.